I'm going to go ahead and get started here. Welcome everybody to LCA Thursday. This is an introduction to Go, and this tutorial is designed for developers, so I'm going to assume that you're already familiar with consoles and command lines. You don't have to be very familiar, but enough to run commands and compile programs and run them. You should be familiar with just programming in general. It doesn't have to be very advanced, but I'm not going to define a lot of terms. I'll define things related to Go, but other things, not spend too much time on defining what programming is. You've probably gotten the Go stick already. It's just got some source code on there. It's also got a Go environment, which you can set up and use if you wish. I made the trade-off for going through a lot of the concepts of Go, so we're not going to do a lot of sit down and type this in now. That's very slow. I want to try to get through as much of what makes Go really awesome as possible. But you have the source code there, and you have a compiler. You can build it and run things and play with things as we go. And we'll talk about that. So who am I? My name is Mark Smith. I work for Dropbox, site reliability engineering in San Francisco. I also contribute to Dreamwidth Studios, which is an open source blogging platform based on LiveJournal. My GitHub is at /xb95. I'm on Twitter, email. Feel free to contact whatever. I can't do. All right, so today's plan. What is Go? Where does it fit? What is sort of the niche that it occupies? What's cool about it? We'll look at a hello world because that's obligatory. Then we'll go into our sort of contrived example program to try to demonstrate as many of the possible facets of the Go programming language and what makes it really interesting, in my opinion. We'll also talk a bit about the anti-unicorns. These are the things that I will be upfront. Go is not perfect. It's only a couple of years old at this point. It's making a lot of progress, but there are still things that are a little warty, and we'll talk about those. And then we'll wrap up, be done, let you out. So Go in a nutshell. Go is a systems level programming language. If you want to compare it to something else, think about the Javas and Cs of the world. So it's a compiled language. It's statically compiled. It is garbage collected, which I think is actually pretty awesome, and you may not. So static typing with some duck typing we'll talk about, has built-in higher level constructs. So it has maps and strings that are actually part of the language, which are really nice. Multi-core support by default. Go is designed for running things in parallel concurrently. It has built-in concurrency primitives. We'll go more in depth into all of these as we go into the actual code. Closures, et cetera, reflection, all the things that you expect from a normal systems level programming language, Go has. I like to think of it as somewhere between C and Python. I've done a couple of years of working in Go now, and when I write code, the same code in Go versus in Python, it typically runs 5 to 10 times faster in Go, and this is just assuming unoptimized code. You can make Python faster, you can make Go faster, you can make slow Go, you can make slow Python, but generally speaking, it tends to work out pretty well. As far as the actual speed for implementation, which is really where Go shines, it's a little slower than working in Python or Perl, but it's a lot faster than working in C or C++. So unless you're, to be fair, there are some people who've been doing C long enough that they can just bang it out. They've got it. And you know what? That's great. I'm not one of them. I'm a little jealous, though. So one thing you'll hear as we talk about Go is very opinionated. Rob Pike and the guys who wrote it, they said, you know what? We're going to build a language that fits a need, and a need that we see is really pressing, but we're going to be opinionated about how it does it. There's specifications on how the code is formatted. They use tabs. They specify a tab width. They specify exactly where the curly braces go. So I've been doing Perl for about 15 years now, and if you go into Perl tidy and all the sort of Perl critic and figuring out how your Perl should be formatted, it's a mess. Python actually, I love Pep8, they actually said this is how it should be done, and that's great. Go goes a step further with Go format, which is you feed it your source code and it spits out the formatted version. You're done. There's no arguing. People try anyway, but Go, when you get into it, they're very opinionated about how to do things. We use mixed caps for things. Capitalization is actually important, and we'll talk a bit about that. Capitalized things are exported. Non-capitalized things are not. They're private. Go aims for being simple and for the compiler to do a lot of the heavy lifting, and we'll go into that, but it really does turn out to work pretty well and make you a lot more productive as a programmer. So let's talk hello world. This is the obligatory example that we always start with to just get a baseline. Those of you who looked at the Go stick might have already seen this. It's pretty straightforward. There's your package. You declare what your namespace is. You can think of it as a namespace. Go will basically bundle everything that has the same package into the same namespace. You can import things. In this case, we're importing the format package or the format namespace. You create your function, your entry points, and then you say format.println hello LCA. And in this case, I talked about capitalization. Println is capitalized, which means it's exported from the format namespace. If format had a function called println that was lowercase, you couldn't call it. So just think of that as we go.
So lowercase is like a private
yes.
function?
Lowercase is private. And you can have structs that have a mixed public-private, but
like within a struct?
Within a struct,
oh, okay.
Yes. So things that are exported and not exported, depending on which namespace is calling it.
But the struct would have to be capitalized then?
Yes, correct. Yeah. So, yeah, go for it. So the question is, what's the final code executable size? Or?
We've got 1.5 megs.
Yeah. So Go bundles the runtime. It's all statically compiled. So every module that you, or everything that you use, or everything that Go uses gets bundled in with your executables. So we're about to build it. So if you have GoStick checked out, this is the point where you can follow along, and we make sure that everything is working. So you should have your directory, and I might be able to.
So you don't need to type the name of the file that you're compiling?
Nope. So is this actually readable from the back, aside from it being too high up? So if you go into your Hello World directory, and you set everything up as in the README, all you have to do is go build. So Go organizes files by directory. It assumes that a directory corresponds to a package. And so if you drop a lot of files in one directory that all have different packages, it'll complain. This is, again, Go is opinionated. This is how your programs should be organized. In this case, we only have one file in here, helloworld.go, which is exactly what we were doing. It has one package. Go knows that there's one package main. Main should have a main function. That's your entry point. So you run it, you get hello LCA 2014. This is not particularly rocket science. But it demonstrates how you actually build things in Go and how you get started. I'm not going to go too in-depth on like the Go compiler. It's got some really interesting technology behind it and like how it works, and it's also really, really fast. So let's go back to this. Did anyone have any particular trouble there, or did you get that?
Just a question.
Yep.
Didn't create any directory structures or anything, but that just worked.
So yeah, so you sourced the bash.sh or zsh.sh in the README?
No, I didn't look at reading at all.
So do you already have Go installed on your laptop?
Yes.
Then there you go. Yeah. So the Go stick was just in case you don't have Go installed. But if you go into the directory and just run Go build and you already have Go, it'll work for you.
Okay.
So I didn't want to.
When I looked at Go recently, you needed to create a different sort of pattern for a layout.
Right. I think this layout's been pretty standard for a while. There used to be makefiles, but those went away a year and a half ago. So.
Just one little thing, it's not really that relevant. On the website, golang.org, it like references it as being able to use like -o for output, which doesn't seem to work. Is that
Oh, interesting.
like
the question.
thing,
Honestly, I've never used -o, so I don't know offhand. I always just.
doesn't seem like it matters at this point anyway.
Yeah, it uses the directory name as the executable name, I believe. So, any other questions?
How did you find the entry point?
So, it knows package main, function main will always be the entry point. That's by definition. So.
No matter how deeply it's nested in the directory structure?
Yes, there can only be one. Well, so if you have two func mains in a package main, there will be the compiler will complain. So, sorry, I need to repeat the questions better. Was there a question in the back?
Oh, no, I was just typing out -o as well.
Oh, wonderful.
I noticed that the first two times I ran it, it was really, really slow. And then
Okay.
the third time was really fast. Do you know why that was?
I mean,
expected to be
I've,
slow the first time. And then
yeah, and then faster the site. Not off the top of my head, I don't know why it would be slower and then faster.
all right.
So it should be reasonably quick to compile Hello World, I hope. So,
The compile was fast. It was the actual
Oh, running of the,
Yeah.
okay.
First two times.
Not sure. So, all right, let's get real. Or let's talk about something that's actually more substantial and talk about more about what Go can do. Go is, as you might expect from a project that comes out of Google, particularly well suited for network services, which seems to be by and large what a lot of people are writing these days. I work for Dropbox. We do a lot of network services internally. A lot of companies are doing that, moving to service-oriented architecture. Go fits really well in there. Similarly, the standard library is comprehensive. If you're doing anything related to networking, HTTP, SSL, crypto, things like that, the standard library has pretty much got you covered. JSON, RPC, et cetera, et cetera. Today we're going to build an echo server, or we're going to start here. So this is going to be a, let's talk about what this is. It's going to listen on a port for TCP connections, accept connections, read some input, write some output. This is pretty standard. You've probably all played with echo servers in the past, or written them for learning network programming. So I mentioned the standard library. It's pretty decent. I will say, caveat, that it's fairly young. Go is a fairly new project, so you will probably find things that either are missing because somebody just hasn't needed that feature yet, or things that from time to time there's been a bug or two, or things that were RFC in compliance. Also, optimization is a big thing. A lot of the things, particularly on the crypto side or the heavy math side, they're just not fully optimized yet. Like they haven't gone through years and years and years of hammering to get them down to the best possible speed. So if you're going to build something that really depends on speed, like if you really need that performance, Go may not be what you're looking for today. It may not fit very well. I think in a couple of years it will. It'll get a lot better. I don't think it's ever going to be as fast as like hand-tuned C, but it'll get pretty close. So searching. This might seem kind of obvious. Don't search for like Go network. You won't get anything useful. Everybody uses Golang, which is golang.org, but it's also the keyword that most people use. So if you search for Golang foo, you'll get stuff. In this case, Golang net will pull up the network package. So let's go back to our echo server. Listening for connections. If you look in the network documentation and just search for listen, so you're programmers, you probably know you're going to look for a listen function. You go to the network documentation, you search for listen, you find this likely suspect. A listen function takes 2 strings as input. This is one of the things that helps you out a little bit with your productivity, I mean a tiny bit. If you're going to have repeated variables so that are like 5 integers or 5 strings or something, you don't have to say string 5 times. It knows like if you don't specify, if you just do net, comma, listen address, string, those are both strings. I like it. Meh. Return values, it returns 2 values, listener and error. So we've got our hello world. How might this look if we were to actually call this function? So instead of importing the format namespace, we have the net namespace. You're importing a package from the standard library. You import it by whatever the name is. Then calling something, so unlike Python or Perl where you can have exported things into your namespace, namespaces are always hermetic. You can't import something from another namespace into your namespace. So if you're going to call something in net, you always have to call net.listen. And similarly, any sort of structs or types or interfaces that are exported are always going to be net.whatever. So you'll see as we go into this, there'll probably be a lot of net dots or whatever if we're calling something in that package. Similarly, you can't import println from format. You could wrap it, do whatever you want in your own namespace, but so in this case, I'm not going to go too much into the specifics of what the arguments are. It's TCP, and we're listening on any IP or any interface, port 9000. Yes, we're about to go into that. Variable definition in Go. So if you've ever used Pascal, tell me there's somebody, maybe? Yes! You've seen colon equals, although it works a little differently here. Go has 2 ways of declaring variables, explicit and implicit. And this is, when I talk about productivity for developers, this is one of the ways that Go really shines. You can declare var foobar as a uint64. That's great. If you want to do that for all of your variables, you can. That's fine. But if you're calling something that returns a uint64, and you have a variable on the left side, you can just tell the compiler, I want to declare this variable. Figure out the type. Colon equal is a declarative assignment. That says, this is a new variable. Declare it, figure out the type, give it the return value. So we don't have to have a var foobar uint64. You can just do foobar : equals something, and it gets declared. You get full static type support.
So if you have declared it, and you're using it, it would be foobar equals.
So the question was, if you had already declared foobar, it would just be foobar equals, and yes, that's correct. This is one thing that's a great seg into, but if you did do : equals, this would be a new foobar in your scope, which is useful from time to time. You can shadow, do variable shadowing. If you had a foobar and then you did another foobar : equal, you get a new foobar. Which, sorry, how do you get a bunch of? As soon as you leave scope, it goes away. You can't unshadow it within the same scope. But since everything is lexically scoped, then as soon as you leave that block, then your shadowed variable will go back to the original variable. So we won't really, that's kind of an advanced thing. We won't really go too much into here. Oh, sorry, question?
Just one question. Is that also working if you are setting value of some variable, or only if you are setting the return of the function?
So in a couple of cases, it works if you're setting the value. So the question was, can you do this like : equals if you're setting the value explicitly? And the answer is, if Go can figure out the type of the right side, then yes. And so in the case of strings, yes. In the case of integers, I think it'll default to just a int, in which case, yes. But if it doesn't know what the right side is, then no. Question over here, John.
Does it assign value, or is it similar to Python where immutable types can be referenced?
So you mean, does it assign the type of the variable?
No. Is it setting is it assigning it by type or by value or by reference?
Oh, it's all by value. So we will go into that in a minute. So hang that. Error handling. So the other thing that we saw on that function, listen, if you remember, was that it returned two things. And this is, if you're from like dynamic languages, Python, Perl, Ruby, that's fine, you can do that. If you're from more compiled languages, that's a little more rare. But Go supports multiple return values. It doesn't really care. You can do 3, 5, 10, whatever you want. Idiomatically, this means that a lot of the time you will do this, where you say something results, comma, error, : equal, some function. If error, do something else, use my results. This gets a little verbose. Question?
Catching and throwing error exceptions?
So the question was about catching and throwing errors. Go does not have exceptions. So we won't go into the whole panic recover thing, which is a language feature, which does exist, but they don't recommend you use that for catching errors. So generally, the recommendation is you use, or this is like, again, we go back to the opinions. This is how they think you should do errors. And then if you get this, most functions will also return an error. Like pretty much every function will return something, comma, error. And then if you catch an error from below, then here I would say, if error is not nil, return nil, comma, error. And I just pass it up the line. Errors are typed, or it can be typed if you wished. So you can do that as well. So sort of like exceptions.
Sorry.
Follow-on question?
In here, you're returning two values.
Yep.
And you have that, the : equals.
Yep.
So if you had defined only one of those,
Uh-huh.
does it shadow both of those? Or?
No. It will declare anything. So the question was, will this shadow both, or will it declare? It will declare anything that is undeclared, and it will shadow anything that's shadowed, or that is already declared. So error often gets shadowed just over and over and over as you do this. But the left side will just get declared. So Echo Server, we have our listening. Now we're going to talk about accepting connections. So we actually filled this out now. We have listener is going to be the variable that we get back, comma, error. It's exactly like you might expect for multiple return values. : equal again. Like we don't have to define what listener is. We don't have to define error. Error handling, which we just showed, and this is sort of goes back to the panic thing we talked about. You can handle errors this way. If you call panic, the program will basically terminate and drop back traces for all running threads. You can catch a panic though, so you can. That's definitely more advanced and not generally recommended. For loops. So the Go programmers decided, or the language designers decided, that you don't need to have a for loop and a while loop and all sorts of different things like that. You just have a for loop. For loop can take optional. This is an infinite for loop, for bracket. It just runs. You can do for, the normal 3 clause fors that we're used to. That's supported. makes it a little simpler. You get one language construct. We're going to do a for loop to accept clients or accept connections. This is the accept function we talked about. If you want to follow, sorry, I should have mentioned, if you want to follow along with the code, there's a part1.go, which is what we're talking about. Probably most of you have found that. So that's what we're doing right here. That's exactly, should be exactly what's on the slide. Again, we're doing error handling. I mentioned this gets a little verbose. This is, it does. It's efficient, it's effective, it's clear. It can get a little verbose. Continue, like you might expect. And now we're going to call handle client. This is, we're building an echo server. It listens for connections, accepts connections, and for every connection, does something with that connection. In this case, we're going to call handle client. You might also notice, as we're actually writing more code here, the distinct lack of semicolons. They are not particularly needed by Go because of the way they define the language. There's actually like a really, if you look up the language definition, there's a very specific, the compiler or the lexer inserts logical semicolons based on other symbols. So Go is a little more restricted in how you structure things, which goes back to they recommend you use Go format.
But it's not space. It's the new lines. Are they? They're not effective semicolons or anything like that.
So the question was, are the new lines effective semicolons? And so the answer is basically yes. Well, so sort of the semicolons are inserted by like closing white space between certain characters.
Yeah.
So.
Yeah, if you try and bring that first curly onto the next line, it doesn't compile.
Right. So it's a little picky about that. But since they recommend or they specify that you format your code according to their guidelines, seems okay.
So I noticed that your code that you have on my Go stick is spaces, but you said earlier tabs.
So the compiler doesn't care. But if you run it through Go format, which I should have done before I shipped the code.
I'm all for your spaces.
Yeah, I use 4 spaces. I wrote it all. Oh, I think the problem is I wrote it in my Sublime text, which Dropbox specifies spaces. We override some of the Go format criteria. I don't recommend that, but fight it out amongst yourselves.
Emacs will fix that for you.
Yes. Nice. So back to the echo server. The next step is to read text and write to it. So we're back in our net package and our documentation. We search for read, and we can find there's a pretty straightforward read function that probably looks like most read functions you've worked with in the past. You can assume that this is a buffer, and it returns bytes read and possible errors. So we have our function here, which looks a lot like main. It's an infinite loop again, because we're just going to echo over and over. We pass in our client, and then we read and write, but the question is, what is a bracket bracket byte? So we're going to talk a bit about types here. Primitive Go types, like most languages, it has ints, uints, floats, things. They also added like strings and things, which are really nice that most people tend to want to use. They are Unicode. As an aside, Go source code files are defined as UTF-8 files. You can put whatever Unicode you want in the comments, in the strings, anything. Go for it. Int and uint are architecture width, and byte, there's a couple synonyms. Byte is a synonym for uint 8. There's a rune synonym for a uint 32, which is for character storing. That's pretty straightforward. More types. It has the usual suspects arrays, pointers, which are exactly like C for the most part. There's no pointer arithmetic, though. You can't do plus plus or minus minus or whatever on your pointers. You have a pointer or you don't. You can't do any modification of it. Slices we're going to talk more about, but it's a segment of an array. And there's built-in language support for maps or dicts or hashes or whatever you want to call it. And those are not just keys on the left side. You can use various types of, or sorry, not just strings as the keys. You can use various types in your map.
On the arrays and maps,
Yep.
can you mix types inside of them?
You cannot. So the question was, can you mix types inside of an array or map? And no. It is part of the type signature. You can't mix. Sort of. Sorry, go ahead.
Just with the pointer arithmetic,
Yep.
Is that because they're smart pointers? Or?
So basically, it's for the garbage collector. To make it reasonable to do actual garbage collection and keep track of all of your objects, they don't allow you to do pointer math. And also, sort of the opinion is that most of the time, like these days, for loops are just as fast using, or compilers are good enough to do array indices just as fast as if manually doing pointer arithmetic, so you don't quite need it as much.
Are there structures or?
Yes, there are structs. Question was, are there structs? There are structs. They're pretty much exactly like C. We'll go into them in a bit. So what is a bracket bracket byte? So this is an array. Looks exactly like you might expect from most other languages, except the brackets are on the front, not the back. So this is a length array of 4,096 bytes. But if we don't know the size or don't care, we can have slices. But what does that actually say? What is a slice? So slice is explained. This is an array. It's an array of 16 bytes, shorter so I can fit it on the slide. It's got 16 memory locations from 0 to 15, so it's 0 indexed. A3, if you have your array and you index position 3, you get the 4th element. This is all well and good. A6 to 8, if you've used Python or any language that has slicing, you can specify subsets of an array. And in Go, this returns what's called a slice. Inclusive.
Perl syntax and Python syntax. Yeah, Python's the half.
Oh, right, because Python would be what, 6.9?
Yeah. Oh, no, yeah.
No, it's like Python, but my slide might be wrong.
Oh, okay.
So we talked about slices. So if you did declare a slice of bytes, var s bracket bracket byte, it starts out at 0. One of the things that is interesting about Go is whenever you declare a variable, struct, whenever you instantiate anything, it is zeroed. There is no uninitialized memory. You don't have to worry about what's there. If you declare an int, it's a 0. If you declare a slice, it's an empty slice. If you declare an array, it's zeroed. So everything starts at the 0 state. So now we can take our S and we can say S equals A6 through 8. This is now S. It is the same, these are the same memory locations as in the first array. So slice location 0 is exactly A location 8.
So a reference there.
It is a reference, yes. The thing, so to think about slices, they're just windows. You have an array. Arrays are immutable length. They're defined. They have one type. You can create a slice, and you can point it to the array, part of the array. So internally, slices are just a tuple of the reference to the array, start length. Pretty straightforward. The nice thing about slices is the reference types. Everything in Go is passed by value. You call a function, you pass values. You pass it to your 4 kilobytes array, you copy 4 kilobytes into the function. That's great. I mean, if that's what you want to be doing. Slices let you pass references. Note, you could also pass a pointer to your array, but that's a different thing. And if you want to pass pointers, that's great. Slices tend to obviate needing to do that most of the time.
Sorry,
Question?
Maybe you said it. If I change, is S and S and A pointing to the same thing?
Yes. So,
Okay. It's okay.
well, sort of. S0 and A6 in this example point to the same memory.
If I change A0, I'm changing.
Yes.
If I change S0, I'm changing A6.
Yes, correct.
Okay. And vice versa.
And vice versa.
Okay.
The same physical memory.
Is best practice to use a lot of slices or to change one slice? Like in a loop or something like this?
So I think, so the question was what are best practices for slices, and I think that the best practice depends on exactly what you're trying to do. In most cases, I will just redefine the slice. I will just reuse the same, like change where the slice starts and ends. But if you're iterating over an array, there's built-in language support for that, which we'll look at.
Is there an S4?
Sorry, is there a question?
At that point in time, was there an S4?
No. So the question was there an S4 in this example? No, the slice is length 3. So if you tried to reference S3 or S4, anything past the end, you get an index error. Doesn't exist. I mean, then you could change the length of the slice, because you can redefine the slice, right? So you could then say this slice is now 4 bytes long, and then you could do S3. So back to our echo server. We have our handle client function. We have our read function. So we're going to declare a slice. Now, the thing that is a little weird here is so make is how you define certain types in Go. Think of it like new in C. You're saying, I want to make this thing. It's a slice of bytes. I want to make it the capacity to be 4K. So what it's going to do is allocate a 4K array, point the slice at it, but the slice length is 0. So your slice is empty, but your underlying array is 4K.
Is that coming from stack? Coming
From the heap?
The heap?
Yeah, it'll be as much as possible. So I mean, I don't actually, in this case, so Go uses segmented stacks in the Go routines, and I don't know at what point it switches to the heap. So, yeah, question?
I was just about to take notes, and I realized there's something that's not in any of your code, which is comments.
Correct.
Any of your comments.
C style, // or /star. Right, sorry. That's a good point. So in this case, we're making a slice. Again, colon equals, we don't have to declare that buff is a slice of bytes because Go knows we're making a slice of bytes, so it just sets buff to be a slice of bytes. Now we're going to call read. This is exactly like you saw. Again, colon equals, we don't have to do anything. Now we can do error checking. If you've done network programming, this is pretty straightforward. You might get an error, or you might get 0 bytes, which means the connection's closed. Either way, we just return. Again, this function is being called from main and handling a specific client. So when we're done, we can just return. Question up the front.
You can't do if error sort of thing. You've got to do if error is not equal. Like
so no, nil. Yeah, truthiness does not include not nil.
Okay.
So you can only do if foo on a Boolean value.
Okay. And there are Boolean types.
There is a Boolean type. Oh, I lost that in my. I rewrote my primitive type slide and I lost bool. There is a Boolean type built in. And the next step is client write. We read some data from our client. We make sure there's no error. We write it back to the client. This is an echo server, right? Write actually does return some things for error checking, but I ignored those for the purposes of this talk.
And so what happens in memory there?
So when you call client write, it's going to pass your slice. So it passes that tuple of 3 values. And then as far as like, are you talking about when it actually?
The return time, yeah.
Oh,
the stuff that's returned, is that just been garbage collected at some point?
I assume that that's the case. I don't know offhand. So normally, I wouldn't recommend this. I would recommend catching your errors, so and dealing with them. So build and test. You might have already gotten to this part, but if you go into your part 1 directory and run go build, you'll end up with a part 1 executable. And if you run that, and then you telnet to port 9000 on your machine, or anyone else's machine if you have their IP address, you'll get an echo server. And it should just do exactly what you expect for an echo server. Nothing particularly amazing here. Is that working for everybody, or question, or thumbs up? All right. So great.
Just about the array slicing, I'm not sure if you went back with that, but like if you do like a range, it isn't inclusive. It does like the first number and then the second number. You do, like to inclusively, you just have like the number the number in the column. I think.
Yeah. So I get these words confused sometimes, but if you do 6:9, it'll give you a length of 3 slice, starting at position 6, including position 7 and 8. Ending before position 9, which is how Python does it, right? Yes. So it's, yeah. Well, the nice thing is then you can do like 0 colon length of array. Then you don't have to do -1. You know.
Well, yeah, the half open stuff is also nice because you can move a sliding window across it very easily. Actually, Guido posted about that not too long ago.
Nice. Nice. All right. So our echo server is great, but as you might expect with Go being touted as being like great for doing network programming and lots of users and sort of things like that, right now our echo server serves 1 user. It's fully blocking. You telnet to it. If you try to telnet in another port, you can't. It just sits there. Well, yeah, but that's great. So concurrent network programming. You've probably done this in a lot of other languages. And they all have different styles. We could like fork for each child. We could use a threading library, greenlit threads, whatever you want to do. Or you could just do non-blocking with epoll or KQ or or just go back to poll, but that's not how Go does it, so don't worry about any of that. So this is the function we just wrote. We've got our handle client right here, and we've got, our code. And this is actually something I recommend you do in your part1.go if you have it up still. Find this line of code, and you're going to make a change with me here. We're going to add 3 characters in the front of this line. Go space. Go handle client. If you save that, and then you run that, you are now a fully concurrent echo server. You can open up 100 shells, all echoing to themselves and having a good time. You can accept more connections while your existing connections are hanging out. Anything you might expect from a system that supports concurrent users will work.
Is that using a Greenlit library? Or?
So we'll talk about it. Because this is actually one of the core features of Go that really, for me, makes Go worth writing in. And it's what they call Go routines. If you think of greenlit threads, it's that sort of lightweight threading model, where it's done by the runtime. It's not done by the system or the kernel. Question in the back.
Well, I added that code space and built it and now
So
Yeah.
it panicked.
For me, it was the port was already taken.
Oh, that's probably what's happening. So the question, if you get a panic, kill off your old part1 if it's still running, and then run the new one. So and now you see what a panic looks like. It dumps the backtrace of everything. And I guess I should have, yeah. So that works now? Oh God, I cannot type in front of an audience. Really? Awesome. Anyway, so Go routines. These are like greenlit threads. They're lightweight threads. They're part of the runtime support. Go multiplexes M Go routines onto N processes is the technical implementation. And the way that they do it, they're targeting scaling to hundreds of thousands of Go routines. People have reported doing things effectively with millions. It depends on your use case, depends on what you're doing. By default, N is 1, so by default, Go will only ever run one process. You can tell it run 5 or run 20 or whatever. You get control over how many processes Go will multiplex your Go routines onto. Well, question in the back.
Are you able to do that dynamically inside your code? So if you just take the range 100 threads now, you then tell Go multiplex it.
Yeah, so the question was, can you do this dynamically? And yes, there's a runtime package. So you can import runtime and say runtime.maxprox n. I don't know what the behavior is if you go down, so it may only let you go up, but you can certainly do it at the beginning of your process lifespan and just say, all right, I've got 16 cores, I'm going to run on 16. Question?
Sorry, maybe just more detail on those. What are they using for their IPC and what it's using for switching between the Go routines?
So the question was more detail about Go routines. We'll cover some of that in the talk. Basically, the short answer is Go has a custom scheduler, and everything that they've built is pretty custom. So they do use segmented stacks, if you've heard of that. So every Go routine gets a 4K stack, and then when it exceeds that, it just allocates another segment.
What is it using interrupts, or is it using, or is it using at kernel level?
So it's all cooperative multitasking, basically,
Okay. Yeah.
which we will cover. So Go routines, more details. Everything in Go is designed to be blocking. Pretty much all of the standard library functions, your accept, listen, read, write, all of those things are blocking functions. And in fact, pretty much everything is, because in my opinion, this makes software a lot easier to reason about. Non-blocking code can be really fiddly to write. You get a lot of race conditions. You get a lot of problems where you have to worry about what's the state of memory and things going on in your program. But with blocking code, you call read, and either it returns an error, something failed, or it returns some data. It's a lot simpler. Yeah, you still get complexity in anything you write, or you can. So this is how the multitasking comes in with the Go routines, because all those blocking calls, the scheduler will take that opportunity to say, all right, you've blocked, I'm waiting on something to happen, I will schedule another Go routine. Question?
Can you set a timeout?
Yes. You can do non-blocking, and you can do timeouts on your reads and writes and things. And in fact, like if you do any advanced networking code, you're going to have to do that anyway to keep your state going. But for this example, we're not, but it's possible. Like Go doesn't get rid of that. It's just the general paradigm is do everything in a blocking fashion in a Go routine. Go also provides deadlock detection. If it decides that all of your Go routines have deadlocked on each other, using the channels, we'll get into that.
Yeah, the blocking, does that block that Go routine, and it can still swap to other things in that same process?
Yes.
Ah.
Oh yes, sorry. So if you do the part 1 and you rebuild it with a Go, it's only going to use one process because we've only specified one process. But if you can then connect hundreds, thousands of people until you run out of FDs on the same process. And Go in the back end is doing like non-block I/O. It's just, it exposes a blocking interface to you. So, and this is one of the things that makes, like, that stuff that we've probably, like, I'm sure we've all written time and time again in different languages. And it's doable, it's fine. We can do all of this in any other language. It's just that in Go, you do it in 3 characters. It works out pretty well. So we're going to go into V2 of chat. Or V2 of Echo, we're going to make this a chat server, which, if you're thinking about this, is going to involve communication between our Go routines, because everything you type in one connection has to be echoed to all the other connections. So clearly, our current model of having handle client functions that just loop self-contained is not going to work. So let's go into this and talk about communication. Most languages, you'll share memory. You'll have some sort of global queue, or you'll have an IPC interface or something where you have a handle that somebody will take a mutex on, update some data in the global structure, release the mutex, somebody else will then grab it, read data, etc. This is not really how Go wants to do things, because it's notoriously hard to do this kind of programming. Multi-threaded coding makes your hair go gray and kind of difficult. I mean, it's doable, right? Like nothing that Go gives you is stuff that you can't do in another language. It's just that Go makes it easier, or makes paradigms easier to express. So in communication, or in Go, you'll see this quote, like if you read Go documents, everybody seems to love this quote, and it's in like every other blog post. Don't communicate by sharing memory, share memory by communicating. Which, behind the scenes, they implement by sharing memory, but you don't have to, right? Let the compiler worry about this stuff, because, better to have 100 people working on this one piece of software and getting it right, and exposing an interface to you that is easier to use and more straightforward. So now we have this concept called channels. When I say channel, you can think telephone, except that there can be many ends to it. But in essence, you can put stuff in one end, and it comes out the other end. And you can put stuff in the other end, and it comes out the first end. It's bidirectional communication. They're Go routine safe. Like by design, in the runtime, you can pass these channels around. Everybody can be using them. And the runtime enforces safety. So basic channels, and how do we use them, and what do they? You make them. We talked about make a minute ago. You say, I want to make this thing. It's a channel of type int, or channels are typed. They can only take a thing of that type. So if you create a channel of ints, you can only pass integers back and forth. You can create a channel of any type you want. You can create channels of channels. They are first-class objects. So you can have your channel of channels and pass them around. And that's a really useful paradigm for callbacks, because you can call someone and pass them a channel so that when they get a result, they can send it back to you, if you want to do asynchronous functions without waiting for that function to return. Putting things onto a channel, the operator is the less than dash operator. I don't know what to call it. Channel on the left side, value on the right. This is putting a value into the channel. And a kind of strange reading from a channel is, in this case, I'm declaring I as to be whatever the type of channel is, and read something from channel. Question in the back.
So you don't actually have to assign thread and say pass straight into the function using the bracket dash cancel.
Correct. Yeah. So you mean in the second side, like channel, like you don't have to do channel.receive or something?
You don't have to read it into variable.
Yeah, like var ch or something.
Right. Correct. Because like at the very top, we do a declarative equals. Make returns the type chan int, or channel of int. So ch is now a channel of int, integers. Okay. So this is an unbuffered channel, aka it's synchronous. If one Go routine tries to write into channel, it blocks until someone reads from channel. And then when there's mutual receiver and sender, then the data goes to the receiver, and the first one unblocks. Most people end up using buffered channels, where you can say, build a channel and build in a buffer of length 10. So this channel can hold up to 10 integers before it blocks. And this allows you to do sort of like production consumption sort of thing, without having your sender block every single time. So chat servers. So we're going to take our echo server and modify it. And if you're in directories, we're going to part 2 now, and looking at part2.go. But in essence, to do a chat server, you think we're going to have to maintain some sort of global state of connected clients. We're going to have to get that input out of the clients, and we're going to have to write that input back to every client. Pretty straightforward. This is a reduced example. As in all sort of demos or tutorials, I'm not covering every single case, but this will give you an idea of what things do. So we're going to start with storing a list of connected clients. So this is the code. This is the same code we just wrote, the second version with the Go, right? Nothing has changed here except I've added some space, or I've removed some things that we had at the very beginning and added some space. We're back to slices. We're creating a slice. We don't know how big it's going to be, so we don't want to pre-allocate an array size. We just say, we're going to store a slice of net connections. And again, there's that namespace net. And so this is a net.con type. So this slice is a slice of net.con. Then down here, again, just in right above our handle client, before we send off somebody to handle that client, a Go routine, we're going to append our new client to the list. Append is a built-in, which is actually really useful for, originally it was not a built-in, and this got added in, I think, 1.0. But you used to have to say, OK, I've got a slice. I'm going to add something to it. I have to check what the capacity of my slice is. Am I at capacity? I have to allocate a new array, copy my data into it. The normal stuff you do with when you exceed the length of your array and you have to make a new one. Go has it built in. When you say append, if your capacity is going to be exceeded on the backing array for the slice, it allocates a new one, copies your data over, and appends your item. So if that was complicated, it does what it says. It appends this to that.
Wait.
Question?
Yeah, clients is a slice.
Yes.
It's a window into another array.
Yes, the question, yes.
And there's a reference to the data that's already in the other array.
Yes.
So where's the data copying happening?
So the question was, where's the data copying? If clients is just a reference to an underlying array, where's the data copying happening? So when you actually create this up top, there's no backing array, or there's a very small one. But eventually, at some point, you exceed the 10 elements of your array. It has to create a new one. So it mallocs 20 elements. And then it has to copy those. It'll have to copy the elements into a new array. So your slice will then end up pointing to a new array. Does that make sense? So Go defines that you can't grow the length of an array once it's been created. So you either pre-allocate as much as you need, or you have to deal with copying to a new one when you've exceeded the capacity of the underlying array.
Maybe the order of append. Are you appending client to clients?
Yes. So clients is the slice, and I'm appending client to clients, which returns. So this is done this way because append might have created a new slice because the underlying array was exceeded. And in that case, you have to.
So does this implicitly convert clients into its own array?
So the question was, is this implicitly creating an array? And yes. Slices always have underlying arrays.
So I was like, what is going on?
Sorry. Yeah. No, when you define a slice, you either point it at an array that exists, or in this case, it just creates one. It says, OK.
It kind of was an array from the start. It's just reference into an anonymous array that you don't know the
Yes.
dimensions of, really.
A great way of putting it is, in this case, it's a reference to an anonymous array.
So the new memory that it allocates,
Yep.
it obviously allocates this in chunks.
Yes.
Do the chunks grow over time?
No, so it'll allocate, if you exceed the capacity of your array, it'll allocate a new array, but it won't do a chunk and then jump to a new point in memory. It doesn't do segmented arrays. Like it'll create a new full one.
I understand that, but
Okay.
I'm just wondering if it decides to add, 10 bytes and then 20 bytes.
I don't know the exact algorithm, but it's sort of like a binary growth algorithm. So, it'll double every time.
Which means you can't have anything larger than half of your memory size?
I don't know the exact algorithm.
You can't have anything larger than half your memory size.
Yeah.
The whole point is we're not meant to think about this.
Yeah, really good questions, but I don't know.
You should probably repeat them for the
Yes, sorry. The question was, so can you not have since it auto-allocates and doubles, can you not necessarily have an array larger than half your memory size? And I don't actually know if it doubles, so I don't know. So we have our list of clients now. That was our first goal. Now we're going to get input out of the clients. And now so this is the code that we have today. We have our handle client function and our main function with our new clients appending. We're going to add a little bit to this. And we're back to make. And we're back to, I showed the channel implementation on the basic channel slide. But in this case, we're going to make a channel of byte slices. You can make channels of anything, any type, and go. So we're going to make channels of byte slices with a buffer of 10, which means that channel can have up to 10 byte slices in it before that channel blocks. And it's like you make anything else in Go. You say, left side, colon equal, make. We're next going to add this to our handle client, pass it down. You can pass channels like any other variables. They're variables like any other. So we're going to pass that end of the channel into our handle client function, which we then have added that to our type signature or function signature. But now we're going to actually say, you know what? We're not going to echo this back to the client. We're not going to write back to the client. We're going to send this buffer back into the input channel. So we create our channel. We pass it into handle client. And then instead of echoing back to the user, we put the byte slice, which is buffer, into the channel. And so in theory, anybody who reads from that channel now will get this buffer. So the first person who types something, that goes into the channel. Now somebody could read from that channel and get this byte slice. And they could do it in any Go routine without worrying about race conditions or memory synchronization. So this is the changes we've made. And I sort of explain it, so I won't spend a lot of time on this. But in essence, handle client is still all blocking. The read still blocks. The putting things into channel may block, depending on if the channel's full or not. Main now has a list of channels, or a list of clients, and some channel that all of the Go routines will be writing to. And we don't have to worry about, from the Go routines perspective, we could have 100 people connected. They're all writing onto this channel. We don't have any mutexes or anything to worry about. The runtime deals with that for us. You could implement that if you want, and we can, but we need one more piece, which is the piece that reads from the channel and does something with it. So we're going to build a chat manager. This is the code we've already got. We've seen this. We're going to create a closure, which is pretty much like you'd expect. It's an anonymous function, which you then call at the end. But we're going to put it in a Go routine. You can make Go routines of any function call. You can say go whatever, go func to do a Go routine closure. So we're going to put stuff in here. We're going to create our infinite for loop. And we saw the syntax for reading out of a channel. This is simply reading out of the input channel. Declarative equals, so we're creating message from the channel. And since we know what the type on the right is, which is a channel of byte slices, message is now a slice of bytes. And when this runs, and when somebody types something, this will get whatever they typed. Are we following that so far? Awesome. So the next thing, the underlining is a little weird here because this is an underscore character for underscore comma clients equal range clients. Let's talk about that. Range and underscore. So this is the line of code we just had for underscore client colon equals declarative equals range of clients. Range is it's iterating over data structures, slices, arrays, maps, channels too. Go just says, you know what, everybody does this. The compiler knows what's on the right side and knows how to iterate over that very efficiently. So we're just going to let you do it. Like you don't have to write for loops and do stuff. You just say for key comma value colon equals range of data structure. And the compiler just does it. But the thing is, in this case, I don't care about the index. I don't need to get the 0, 1, 2, 3, 4, et cetera, because that's irrelevant. So I say underscore, which tells the compiler, I don't care about this. Don't create a variable for it. Just ignore it. This shows up in a couple of places. This is very common. If you are calling a function and you want one or two, or sorry, thing in the back.
Is it possible to create your own iterable types that you can use with range?
Your own iterables? The question was, is it possible to create your own iterables? And I don't know offhand if reflection, like if you can define a type that does that. Since you can create slices and arrays and maps of any type, then it's a little less useful. But I feel like there is. Like you could have a Go routine where you could range over, but I'm not sure offhand. So again, underscore is anonymous, or the blank identifier. Can be useful if you don't want to create a variable for something. So back to the code. We have our for loop where we iterate over the range of clients. And then this is the exact same code we had earlier where we do client.write. But in this case, since we're doing it here for every client, so this Go routine is running once globally, because this is in our main function. We spin off this Go routine. It just loops on this channel, receives a byte slice, then loops over every connected client and writes that byte slice to those clients, and then goes back to reading on the channel. And this is all blocking. This blocks and that blocks. So when I said that this demo has been a little elided for some safety concerns, like, yes, you could end up in a situation where this is blocking and then nobody's getting anything. Question?
Yeah, is it also a site because you're writing to clients in the main routine and now you're reading to clients in a different routine, and when you replace clients, is that atomic or is it dangerous?
So clients, yeah, that's the other dangerous point. The question was, since I'm working with a client slice in different routines, is that atomic? Slices are, this case is a little safer. It's not very safe. They're not defined to be atomic, is the short answer. Maps are also not defined to be atomic. If you need atomicity, the Go way of doing things is using channels. There is, however, a atomic package, which gives you that functionality if you want mutexes and things. And from time to time, those are useful. In this case, I would probably just use a mutex because updating it is a lot lower incidence than using it. But that is definitely not safe in this. So.
Can you assign that coroutine to a method and then, or to a variable and then call it later?
Yes. So the question was, can you assign? Well, can you? The question was, are Go routines first order things? Go routines are not. Functions are.
I'm sorry, the closures.
So the question was, are closures first order things? Yes, I believe you can. I haven't tried that. Functions are. I don't know if closures are, is the question. But since it just has a type signature of func, I think you can. So.
I can pass a function to some other.
Yes, you can pass functions. The question was, can you pass functions? And yes, they're first order. So build a test if you want to give this a shot in your part 2 directory, or this question up here.
What's the the parentheses at the end of that anonymous closure?
So the parentheses at the end actually invoke it. So you define the function, func parenthesis for the calling, and then yeah, that forces it to be called. Go routines only work on method invocations. It basically, what you say, go this thing I want to call, and I'm calling it now, which will then spawn into a new Go routine. So it has to be called. How am I doing on time anyway? 30 minutes? No? Yeah, okay. All right, so build and test. Probably have to pick up the pace a little bit. So we're going to go into 3.0, which I'm calling Frotzer. If any of you have played Zork, you may have heard the term. If not, then it's going to be completely irrelevant. So we're going into fairly contrived examples here, but I want to talk a bit about Go is not object-oriented per se, but it has language support for functionality that gives you most of what OO gives you, polymorphism and the like. So what we're going to do is we're going to build some behaviors that we can apply to the messages before they get echoed back out to the users. So more type talk. We talked about structs, or mentioned them a little bit earlier. You can say type of something is a struct. So in this case, I'm declaring uppercaser as a struct. Normally, you would say, in fact, actually, I think my next slide is struct bracket bracket or curly curly. So you can define empty structs in Go, and they're actually useful for defining as types because Go does not have classes. You can't say this is a class of foo and it has these behaviors. But you can say this type, foo, is a named struct. And it could be an empty struct for all Go cares. And so that's how you can say, I want to create this thing, give it a name, and then I want to hang some methods off of that name. So if we look back at the example here, we have our uppercaser, which we define as an empty struct. So as far as Go is concerned, if you create an uppercaser, you get an empty struct. It's just that as far as the type system is concerned, you have an uppercaser. Behaviorally, it's an empty struct until you create methods. In this case, we're creating a frots method that takes a byte slice, returns a byte slice, and is on uppercasers. This is the method receiver. So now, any uppercaser you have has a frots method, where you pass it a byte slice, it uppercases that byte slice, and returns it. Question?
So how would you actually define all of these in your code? Because I would expect you have multiple structs, it would get quite confusing. So would you define them as files, or is there a way to function definition inside the type?
So the question was, how would you define these in your files so that it would be not so confusing if you just had these one after another? You can create separate files, and if you do create another file in the same directory and put package main on it, you can organize your code into as many files as you wish. And as long as they're in the same directory and have the same package, Go will bundle it together in the compilation. In this case, if we go into part 3.go, I just have them one after another in the code, which works for this example, but kind of up to you.
So sorry for those questions. Just with the structs, though, is that like the Go style to like use a struct in that situation? Because traditionally, I would have expected like to have just a global function, I suppose, in that situation or something of that nature.
So the reason we're using a struct is because we're going to go into Go's pseudo object-oriented nature, or the way that you do OO or in Go. You could have a global function here, and that'd be fine. You'd have your main.frots and whatever, but this will become relevant shortly. So struct, instantiating a structure, just so you know, is type bracket. If the structure actually had members, then you could say bracket, if it had an A member, you could do A:5 or whatever. And then you can call the method on the struct or the method on the type. So interfaces. In Go, an interface, so if you've done Java, you're familiar with interfaces. It's a collection of behavior. You say, this is my interface, it does these things. And you don't actually implement those, you just say, these are the things that this interface can do. And anybody that implements those in Java can say, I implement or implements I blah, 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 blah. And you specify that you implement an interface. And then somebody else can say, I receive or I take things that implement this interface. And that's great. Go has that in essence, except it's implicit. It's basically duck typed. In Go, you say, I want to define an interface. So type frotzer is an interface. And this is very idiomatic. ER stuff will be interfaces. You'll see io.writer, io.reader. And they're things that implement read and write. So frotzer is an interface, and it has this method, frots, which takes a byte slice and returns a byte slice. And so now, as far as Go is concerned, any type that has this exact method signature is now a frotzer, period. It doesn't matter what, you can't say I am not actually a frotzer. If you implement that method, which we do on uppercaser, uppercaser now implements this interface. Correct. The question was, it doesn't matter if it's a superset. Right. As long as you implement this set, you can also implement many other sets. It doesn't matter. And the compiler enforces this. As far as when we go into using a fraudster. If you recognize, so this is the code we wrote a minute ago. This is our chat manager, unchanged so far. But what we're going to try to do here is pass in some behavior to our chat manager. So what we're going to do is pass in a fraudster. We're going to say, third argument, frauds, is a fraudster. And when we call client.write, we're going to pass message through the frauds function. So as far as this method is concerned, it doesn't know what you're passing it. It's just specifying that it takes the fraudster interface. That's it.
If you had used a function pointer, you wouldn't have been able to have used the generic interface, then is that correct?
The question was, if you had used a function pointer here, you could not have used the generic interface. Yeah, in that case, you would have to pass, well, so you could define a function as a type and then say, I take functions that match this signature. And then you could pass any function that matches that signature in. But then, of course, the calling would be different. You wouldn't have a receiver on the left side, or the fraud dot. You would just have the method you're calling. So you can do that as well. So now we're going to build some fraudsters. And if you've looked into part3.go, you've seen these now. We've got uppercasers and lowercasers, and you could add whatever you want. And as long as it implements this method with that signature, then that type is now valid for being passed to Chat Manager. We'll go through this implementation. So let's actually do this. If you remember our original main from part 2, we had a closure there that we passed into, we called go, func, stuff. I wanted to actually pull that out because I like my mains to be pretty short, straightforward. I don't like them to have a lot of behavior in them. So in this case, I created a new function called Chat Manager, which takes our client's slice and input channel. And we're passing the channel onto Chat Manager. And we're running it off into its own Go routine. So there's functionally no difference here with what we had. Question of that. Good eyes. The question was, why is there an ampersand before clients? So this is an implementation detail. The problem was, since I'm now passing the slice down there, and if you remember, like we had a discussion a bit ago about this clients equal append clients client. The problem is, as soon as that underlying array changes and becomes a new one, as soon as we exceed it and allocate a new one, whatever the reference we passed in, if we don't pass in the address of the variable, is invalid. Or rather, it refers to the old one. So, because this ends up being like, clients ends up being a new slice, right? If append might decide to create a new slice for you, in which case this variable changes. So we actually have to pass the address of the variable into Client Manager so it always has the current slice, which is only a function of, originally I did it as a closure so I didn't have to do this, but then when I wanted to do this behavior I had to do it anyway, so. But does that make sense? Okay. Reference. So it's exactly C style. You can take the reference of a variable with an ampersand, and that's a type of, in this case, the type of this is star bracket bracket net.conf, a pointer to a slice of net connections. Question?
You were saying earlier that the append could change the pointer type. So what if someone forms an append while you're sending information back to your
right.
client?
So the question is, what happens if someone is, if this is appending while Chat Manager is using the clients, right? So I haven't actually thought through all of the implications. It's probably safe because this will be either atomically adding a new item to an element or atomically changing, returning a new array. But it's still just generally, probably generally bad form to do that.
We were saying automatically deadlocks checks, doesn't it? So if you're dynamically growing memory, it should be able to work out and access at the same time. Right?
So the question was, does it, since it detects deadlocks, will it actually be able to detect if there's a memory collision? No. So the deadlocks are mostly around channels and use of the inbuilt Go concurrency model. If you're sharing memory, which is generally frowned on, then it doesn't do a good job of detecting that right now. There's a Go race detector mode where you can run your program in race detection mode, where it actually does do like guarded access of memory and tries to find people accessing the same memory. But by default, that's not enabled because it's a big hit. So we abstracted out our closure into a chat manager function. But now we're going to, as we showed a minute ago, we added the third parameter, which is a frotzer. And now we're going to pass in a lowercaser and an uppercaser. The curly braces on the end denote that we actually instantiate the object and pass it on down. Chat Manager just takes a frotzer. It doesn't know that it's getting a lowercaser or an uppercaser. It says, I take the interface frotzer, and the compiler determines, because it's all statically typed, that uppercaser satisfies frotzer, so it's a valid interface, or it's a valid object to be passed into the function. So why do I have two here? What's going on? I wanted to sort of demonstrate sort of the safety or the concurrency of channels. You can have multiple Go routines receiving on a channel at the same time, and you don't have to worry about mutexes or guarding who is doing what when. If you're using channels, it is safe to do in multiple threads at the same time, writes and reads. The runtime enforces that. In this particular case, or at least on my machine with my compiler, when I built it, it interleaves. That's probably going to be true for the rest of these as well. So you end up with one line will be uppercased, one line will be lowercased, one line will be uppercased, etc. And again, Chat Manager doesn't actually know what you're giving it. So we can build and test this. If you have your part 3 directory, if you've probably been playing along, you've probably already done this. If you build it, you can telnet in. You can do multiple connections. You can type things, and one will be uppercased, probably. One will be lowercase, probably. Hopefully that worked for at least a couple of you. And that's pretty much the example we have there. So kind of as review here, in like 45 lines of code, we've built a multi-user chat server. I think it covers a large part of the big parts of Go. The concurrency model, the built-in ability to run things off into different Go routines. The interfaces give you, in essence, some features of object-oriented programming, right? You can do polymorphism in the sense that you can have multiple interfaces, and as long as your thing implements those interfaces, it can be passed to anybody who takes those interface or takes an interface of that type. It's still statically typed, so you get all of that while still being able to ensure that when you compile your code, you're passing things that could conceivably be frotzers in this case, right? You can't, if you tried to pass an int or something, it wouldn't work. If you created a type of foo that was an int, and then you created a function on foo, then you could pass a foo type, right? Because foo implements that, but you couldn't just pass an integer. So Go is pretty awesome. I would like to have like unicorns and bunnies on the slide, but we're going to talk about things that are not quite unicorns yet. So Go is garbage collected. And if you've worked with garbage collected languages, this is a mixed bag. Personally, I think it's fantastic 95% of the time, and annoying or downright troublesome the other 5% of the time. Not having to worry about memory allocations, particularly in multi-threaded environments where you have to figure out like and see, oh wait, who actually has the responsibility of releasing this thing, and how do I track that? That gets really painful. In Go, you don't have to worry about that. You can pass this reference around all your different channels, and as soon as it goes out of scope, the next GC cycle will pick it up. It's a parallel mark and sweep garbage collector. I really like it. I think it makes programming a lot easier. Question?
How tunable is it? Or is it just
So it's not very tunable right now. The question was how tunable is the GC? Not very tunable right now. And so that's on the not unicorns yet slide because it is not, the GC is not fully, it's young. It's a couple years old, right? I mean, it's based on established technology, but it still has some rough edges. There's some good debugging. Like you can specify an environment variable that says like GC debug 3, and it'll print out all of the stuff it's doing. But I ran it, I was doing some, I was trying to do a TCP dump or libp cap on 100,000 packets per second the other day, and allocating a buffer for every packet, and it was just, the GC was like, no, nope, nope, nope. So in that case, I mean, you can do the standard tricks you do, right? You have a free pool, you put things back in the free pool. Like, you know, it's not hard, but you have to fall back on some of those things. It's not quite magical.
It doesn't have a free though, I
correct. The question was, does it have a free? No, there is no free in Go. It's all, the GC should take care of it for you. The standard library is pretty young. I mentioned that earlier. There's a lot of functionality there and a lot of room for contribution if you're into that. But it's definitely missing some things and not fully optimized. And the ecosystem is still small, but welcome. So the scheduler also is worth kind of a shout out. We talked a little bit about the rough edges on it. There are some, particularly certain workloads. So it is a cooperative scheduler. So if you are doing a lot of intensive math and you're never actually blocking, then the scheduler can't jump in. Recently, I think 1.2 added the scheduler gets invoked like every n function calls. So if you're doing function calls, the scheduler will also get invoked sometimes, which helps. But if you're just doing a for loop that does some calculation, you'll starve the rest of the Go routines. So on your process.
Is there a trampoline call or a sleep or something you can do to?
So the question was, is there a trampoline? Yes, there's a runtime schedule, or something like that. That's basically saying, oh God, please help. So yes, you can. You can specify as an environment variable Go max procs to say how many processes to run with. You can also specify it at the beginning when you run your program. You have to play with it because it's not like, as soon as you get into multiple processes, when you're dealing with channels, and if there are 2 Go routines on 2 processes that are communicating a lot, there's a context switch for every communication, right? So to pass, and a lot of locking. So it ends up being a lot more complicated or a lot more work for the runtime than if you just have one process where there's a lot of just internally.
How does that scale?
So out to multiple processes?
Yeah, you just adding complexity, get n squared or something, or is it linear? Or?
So it depends on, it depends on your workload, right? Like what you're trying to do. I don't actually know the complexity of the scheduler. I think that it runs up to like hundreds of thousands of Go routines, so it seems to be fairly decent.
What about for your chat program here?
So for the chat program there, it'll go really well because we're not doing a lot of back and forth between the Go routines. The point where it breaks down is if you're trying to do if you're trying to do a parallel computation and you need to pass data back and forth like a MapReduce style kind of thing, then it'll break down because now you're passing data between possibly different processes because there's no, the scheduler doesn't have a way of saying, these Go routines are talking to each other, let's put them on one process. It'll just shard them out across all the different processes, and then you can run into the performance problems. But if you're doing so for most network programming, or if you have a client and all of the processing is going to be in your Go routine, it works out really well because then there's not a lot of crosstalk. So, and we get back to network services where Go really shines. Question?
When the scheduler kicks in, can you assume that all your Go statements themselves are atomic, or might it kick in whilst it's...
So the question is, when the scheduler kicks in, can you assume that everything, as far as Go is atomic? And the answer is yes. It's not going to unschedule you in the middle of an operation because it's got very finite points for where it schedules based on function calls or function boundaries and blocking calls. So you're guaranteed you're not going to be in the middle of a map update because it's not preemptive. So, question in the back.
Countering that, you can actually have more than one hardware, more than one process underlying, more than one thread. So it's not really a useful guarantee.
Okay, so yes, the point was since you have multiple processes and the scheduler can be running across each of them, it's not a useful guarantee. I think that they've guarded against that a lot by, I think the scheduler runs in one place and it just dictates which thread is running on which process, but...
Global interpreter lock.
Yeah. Reinvented the guild.
So I will admit that we're now past my knowledge of the depths of the understanding of the scheduler. So I will cop to that. I don't feel like there's a GIL. I haven't heard anyone complaining about a GIL, but it is. So we did not cover a lot of things with Go. It's actually a pretty deep system. There's a lot of stuff you can do with it. How to build your own packages. One of the things I really like is you can import from GitHub or Launchpad or whatever you want, which, yes, I see your face. Well, it doesn't happen at build time. Yes. It's really, so when you say, so the Go tool, we've been doing Go build, you can say Go get. So you can say, go get this thing, and it'll say, oh, okay, it depends on these, and I can go fetch those, and blah, blah, blah. Which, since there is nothing like, there's no PyPy or CPAN for Go, it's a nice utility. In production, we don't do it that way. So I will say, so at Dropbox, we have very specific, like we check out all the code that we're going to be building from. We have like a third-party repository. And when we build things, we just build against those. So we have stable versions, and we upgrade them when we need to, but not optimistically from GitHub. Because, yeah, but for development, Go format, do it. Recommend it. Switch and select. There's a lot of really nice, if you have like 5 different channels and you just want to have a function that, possibly it could be reading from this channel, it could be writing to this channel, it could be doing these other things, you can just use select and say, here are the different operations you can do on these channels. Do them when they're available, default, something else. You don't have to write your own select logic on multiple channels. So this gets around a lot of the blocking problem. Like if you have multiple things you want to be pumping at the same time, you don't have to create like 4 Go routines and then try to multiplex them. You can create a select that deals with your 4 channels, which ends up working out pretty well. Type assertions, reflection. Type assertions, not type casting. You can, okay. We didn't really get into, there's sort of a void star in Go. It's the empty interface. Everything implements the empty interface. So you can declare a function that takes an empty interface, and then you can pass anything you damn well want. And there's sort of mixed bags there because then the compiler can't help you as much. But it's possible. So Go doesn't completely constrain you on that regard. You can do crazy things.
If the compiler can't help you, does it generate an error?
So the question was, if the compiler can't help you, does it generate an error? In this case, no, because it assumes it won't generate a compilation error because you're saying interface blank. So you're assumed to know what you're doing there. But if you do try to assert that this interface, so you pass in an int to something that takes a frotzer, and when you run it, it'll panic because int does not actually implement that. So it'll do a dynamic check. So it moves it to that stage as opposed to doing it compilation. But if you need to, you need to. Reflection, all sorts of the stuff that you normally expect from a language, Go pretty much has it. Except there's not really a good Go debugger yet. But that'll come. So thank you. I have some really good recommended reading. Effective Go, I think, is my favorite. Like, it's a really good, here's like how you do stuff, and it's at the technical level, like for programmers. It's not a very long read. I definitely recommend that. The FAQ has a lot of good stuff like, why a garbage collector? And like gives a lot of feedback from the designers. There's a lot of talks and presentations. And there's the Go playground, which you can go to play.golang.org, type in your Go code, and hit run. And it'll just compile it on the remote server and run it for you. Obviously, you can't do network stuff. Like the timer and sleep is disabled. But if you just want to like bang on things and see if they work, I highly recommend that. Again, I'm Mark, SRE at Dropbox. We're hiring if you like Go, if you want to do Go, or if you're good at Python, you like big systems and lots of data, then we're definitely always looking for people. And do I have time for questions? Or? Yeah, OK. Start over here.
On the channels, are there any ordering or delivery guarantees on those?
So the question was, are there ordering or delivery guarantees on channels? Channels are, if you have 4 people writing, there's no guarantee on who gets to write first. But there is, once something has gone into the channel, there's a guarantee. So channels are ordered, first in, first out.
Even if they're going across to a different CPU and there's going to be a delivery guarantee that you're going to be able to read it?
So I want to say, so the question was, even if you're going across to another CPU, and I believe, yes, that is enforced by the runtime. But then we get into the performance implications of going to multiples, or going across processes. Question, back, blue shirt.
A quick preface, using a lot of languages, looked at Go a little while back. I'm feeling the same way that I did at the time, which was, is this an April Fool's trick? I'm not quite sure. Have you ever felt that way when you first getting into Go, or is that just...
Yes, so the question was, like, I've looked at Go a lot, and to paraphrase, like, it looks really good, but is there, what's under the covers? Is it kind of a trick, maybe? Or is it an April Fool's trick? And yeah, so I tried to mention some of the anti-unicorns around the GC and stuff like that, because certainly a lot of so I do a lot of network work, and I want to run something that, has 5,000 servers report the version of a certain amount of software. And writing that in Go is like 50 lines of code. and it's parallel. All the servers can connect to it. I don't have to worry about non-blocking I/O and dealing with all those cases. I spawn off a Go routine for every listener, and it just works, and that's great. So for certain situations, absolutely. It feels like a magic trick. It works really well, and I love it. For some other situations, I didn't mention, somebody asked about Go routines having handles or being first-order candidates. A Go routine is not. Once it's going, you can build in some infrastructure to send a channel to it and say, hey, please quit, but you can't kill a Go routine. And this is, I've done some sub-process work where I spin off another process, and then the only way I can kill my Go routine is to have the PID of the process, which I then ask Linux to kill the PID so that my Go routine exits. And it's like, I should be able to exit or end a Go routine, but there's a lot of state problems with that. Like, how do you kill it? When do you kill it? What happens to the memory it was using and cleanup, and so you can't yet. So there are a couple of situations I've run into where it's like, okay, this is a real language after all. It's got some trade-offs you have to make. But for the most part, I've been pretty happy with it. Question?
Are there any user interface libraries?
Sorry, are there any users of?
Are there any user interface libraries, like the GUI?
Yes, so the question was, are there any user interface libraries? Yes, I've seen some people doing some Windows coding with it, but also some Cocoa coding, or what do they even call it these days, and GTK. So there's at least a couple, like a GTK library. There's a what? There's a Qt library as well. So yes, there are some people doing that. I don't know much about it, but yes.
How much is Go used at Dropbox?
So the question was, how much is Go used at Dropbox? So the really brief history is that Dropbox was this big tarball of many lines of Python that was called MetaServer. And over the past year or so, we've started breaking things out into services. So we're moving to a service-oriented architecture. And I would say our new, if you've used the Dropbox Data Sync API, it uses a backend we call EdgeStore, which is all a Go product. A lot of our internal tooling is now built on Go, the version watching framework I mentioned. We're moving a lot of our monitoring, because once you get to tens of thousands of machines, Nagios tends to break down. So we're looking at doing that in Go. So I'd say at this point, it's on the order of 10 to 15%. We want it to go to a lot higher. I mean, so it's kind of a trade-off. Python is still really, really good for iterative development, for getting things out quickly. The libraries in Python are fantastic. There's a huge swath of things. If you just want to do it, Python does it. Understanding Python code and debugging Python code is actually pretty straightforward and easy. And if you don't need concurrency, you're probably still faster sticking off with that. And if you don't need the performance of a compiled language, that still works out pretty well. But Go tends to be really good on the infrastructure or network scaling side of things. Question?
Does that mean all the Dropbox clients are Python then?
The question was about Dropbox clients, and yes, they are Python. So for the most part. So I'm not a client developer, but I know that there's a lot of Python in the clients. So more questions in the back.
Yeah, not to be trolling here, but there's a lot of C-like concepts,
Mm-hmm.
with pointers and packages and scraps and all that kind of stuff.
Yep.
Which I guess you don't see as much in modern languages today.
Right.
Why not just use C?
So the question is, why not just use C? Yeah, no, in essence, it's a programmer productivity thing for me. C can do anything that Go can do, and it can do it faster as far as the implementation once you've got it. But getting there can be more challenging.
First class stream.
Oh, okay.
If you had the line count to the programs he wrote and a C app that did the same thing, it'd probably be pretty substantial.
Yeah.
It's taking a long time to be able to write C quickly.
There's that. Yes. But C is great. We use C at Dropbox for a couple of our things that really need to be performance critical and handle a million connected clients or millions and millions. So, question?
Who else is using Go?
So Google obviously, or question was who else is using Go. There's actually a page on, I think on the wiki that has a lot of people who use Go. SoundCloud, if you've heard of them, they're doing a lot in Go. GitHub has published a couple things. Google obviously is using Go. Brad Fitzpatrick's given some talks. And Dropbox is starting to use it. It's more and more people are starting to use it for smaller pieces of their infrastructure and aren't yet at the point where they're giving talks and publishing things. But there's some lists online. In the back.
Are there any IDEs at the moment which take advantage of the static typing, for instance?
So the question was, are there any IDEs at the moment? I want to say there's something based on Eclipse. I use Sublime Text for Mac, and there is a Go Sublime plugin, which does a lot of the sort of the code introspection where you can say autocomplete and see what is this type and what does it do, what is this function. So sort of. Yeah, there are official libraries for Vim and Emacs. I don't know exactly what they give you though.
In Vim, it's got sorry.
There's also a plugin for IntelliJ as well.
So there's also an IntelliJ plugin.
I was going to say in Vim, there's like syntax and highlighting, and there was something I think where you can compile as you write, but I didn't bother with it.
Any other questions over here?
You said that you are deploying the application that are getting a lot of connections and everything. Are you actually restarting them like every night just because of some memory problem, or they are just running?
So the question was, like, for the Go applications that are getting lots of connections, do I have to restart them periodically, or do they just keep running? So far, the version watcher thing that I wrote has about 7,000 machines phone in every 2 or 3 minutes and report a bunch of things, and then they disconnect and go away. And that's been running for months, and I have to restart it when I upgrade it, but otherwise I haven't had any problems. Over.
What's the story with it being statically linked? I sort of thought that shared libraries were a good idea to explode in them and
So
virtual memory and things like that.
So the question was, what's the story about it being statically linked? So I can tell you that I don't know the official story, but I can tell you, so I do site reliability engineering at Dropbox, and I will tell you that I don't really like dynamic linking. Like, there's a lot of really nice things as far as like, okay, yes, I could upgrade libc and then restart all the programs and they get the new libc, and that's fine. I don't have to recompile things. But Go compilation is so quick and fast and painless that I don't care if I have to recompile 50 things. It'll take me a minute and a half or less, and then I can just push those out. So I also really like being able to just put a binary on a machine, and I don't have to worry about, does it have the libraries? Does it have the right versions of the libraries? Or is this the weird Ubuntu 10.04 machine that somebody installed the random raring kernel, and I didn't know about it, and now my binary doesn't work anymore because of some weird edge case. Like, I like to compile, build, and test a binary, and then ship that out to production. That's my opinion. I don't actually know what the Go author's state on the matter is.
No options for dynamic link? No.
Correct. There are no dynamic link options for Go.
It actually comes from Google's practice that all their services have to be pretty much self-contained. They're giving a pure root with absolutely nothing in there. They're not meant to share libraries with anyone else.
So the point was that our static linking comes out of the way that Google does software distribution to production. So.
Do you think Go will ever introduce like generic types?
I didn't put that on the NC Unicorns. The question was about generics. This is basically, it's a hotly debated issue in the Go community. The stance is that they're not against generics per se, but they haven't seen a compelling enough argument for adding them to the language. I don't know if they will or not. It hasn't really, it's only bitten me a couple of times where I thought it would be nice, and I worked around it. I don't know. Question in the back.
When you attach those methods to this struct, what is it about that which actually allows you to do that? You just define the struct and then define the function. Is it just the type of the first argument, or what?
So the question is, what is it about the struct that I have that allows you to attach methods to it? And yeah, it's just based on the type name. Names are, I mean, in this case, you say this type name is this data structure. And to the compiler, you can just attach methods to that type. There's nothing inherent to the data structure that allows you to do that. It's just based on the name. Any other questions?
I use Python a lot and have for a long time. So some of the things I like in there are stuff like decorators, list comprehensions,
Right.
I like exceptions, but you covered that one too. But is there anything that's analogous or kind of similarly? How do you take care of stuff like that?
So the question was, what about analogous things like list comprehensions and decorators? So Go does not have either of those. You can't modify your methods like that. I would say that I haven't written things that have particularly needed those. The list comprehensions would be nice. The being able to filter things. You can so you can do a hack where you can say, like where you do the types, you can say type foo is a slice of x. And in fact, the sorting sort of works this way, where you can say, then you could have functions on x that return foos. And so then you could chain the functions and do your filters that way. And you could make the argument be a func that gets passed the actual type. So, or the actual element from the slice.
So it's trivial.
Yeah, it's fairly trivial. It gets a little verbose, I think. It's not as trivial as the list comprehensions in Python. So,
might be a weird question, but in terms of like Dropbox making like the executive decision to introduce Go as for their corporation as
right.
a language, what tick boxes did it check for them to make that jump?
So, the question was like, why did Dropbox start using Go for some of its infrastructure? And
You're assuming that you told corporate like you're
No, so in essence, developer productivity and there's a class of bugs that you run into in a very dynamic language. Putting the wrong type of something in a variable, mistyping your variable name. Some of these you can fix in various languages, some of them you can't. These things tend to, static typing gives you a little more like consistent, or consistent's not the right word, but it helps you out a little bit more. When you compile something, you're pretty sure that your variables match up, that you're passing the right number of things to the right places, and that everything is a little safer. It's also like the static binaries that you build and ship out are a little easier to deploy in production than doing Python dependencies. But really, I think it comes down to, can the developers be quick in it, and can it build product in a way that is efficient and solves problems? We're not retroactively like going back and rewriting everything in Go. Like we have stuff, it works well. We're looking at new things that we build. If Go is the right decision, and sometimes it's not, we still build lots of things in Python. If Go is the right fit and right decision, then we'll do it. Otherwise, we use Python or go with that. I think we've run out of time. Thank you all for coming. You've been a great audience. I'll be around and the slides will be available. I think LCA is going to publish them, but I'm also going to link them on Twitter. So feel free to follow me. And if you're interested in Go and Dropbox, we are hiring. So thanks for coming.
Prerequisites, Dave.
Well, we can chat.